In today's project, we are going to be replacing this unprotected receptacle with a brand new 20 amp GFCI receptacle. Now, as of the 2020 and 2023 NEC code, it is required to have GFCI protection in all bathroom receptacles, kitchen receptacles, so that's going to be countertop surfaces and 6 feet of the sink. It's going to be laundry areas, which this is, and also basements, unfinished basements, which this also is, garages, accessory buildings, outdoors, crawl spaces, sinks other than the kitchen and bathroom, boathouses, bathtubs and shower stalls, dishwashers and garbage disposals. So it's going to be important to know how to upgrade from this unprotected receptacle to a new GFCI receptacle, which is what we're going to be doing today. You may also notice that this is a 15 amp receptacle. How do I know this? Well, it doesn't have that side slot. See how this one looks a little different? It looks like there's a T. Now, you have to put a 15 amp receptacle on 15 amp breaker. Now, how do I know that I can put this 20 amp receptacle? Well, this wire is 12 gauge. Yes, it looks like 14 gauge Romex that you get now, but it's old. If I look along, you can see, maybe not on camera, but this actually says it is 12-2 right here. It's 12 gauge 2 conductor. So I can put 20 amp receptacle on a 20 amp circuit. 12 gauge wire is going to be on a 20 amp circuit. Now, if you're not totally sure, hey, do I have a 20 amp breaker or do I have a 15 amp breaker? You can look in your breaker panel box when we shut off the power, which we're going to do, but you can also always bet on the side of safety, and you can get a 15 amp receptacle. You can always put a smaller receptacle on a larger circuit, but you can't go the other way around. You cannot put a 20 amp receptacle on a 15 amp breaker. That is not allowed. So in this situation, I do have a 20 amp circuit, and I do have a 20 amp circuit breaker. I have 12 gauge wire, it's good for 20 amps. So I'm going to be upgrading from this 15 amp unprotected receptacle to a brand new 20 amp GFCI receptacle. To get started, let's go over the tools and equipment you might need. So obviously for this project, we're going to need a GFCI receptacle. Get either the 15 or 20 amp depending on what you need for your project. Next, you're going to need screwdriver. I like this Klein. It's a multi-use one, so there's a flat blade on this end, there's a Phillips bit on this end, and it's actually insulated. I mean, I can safely work on live circuits, which I do not recommend for most situations, but I can safely work on live circuits up to, I believe this is 600 volts. Maybe it's 1,000. Yeah, 1,000 volt rated is what the handle says. It's basically plastic up until the very tip, so I can touch this and not get electrocuted. Next, I recommend a non-contact voltage tester. This one's Fluke. Klein makes a really good one as well. This is just a Klein, I guess, outlet circuit tester. So you plug it in, and it's got various different configurations and lights, so it'll tell you if it's correct, hot, neutral, hot ground reversed, open, hot, open, neutral, open ground. Definitely recommend getting one of these. Not totally required, but you can get away with maybe plugging in a lamp, but this is the best solution. Recommend having some sort of wire strippers and pliers. This is a 2-in-1, so this is plier tips at the end, but wire strippers and cutters along the tool. This is made by Knipex. Really love this tool. I've gotten a lot of good use out of this. And then I also recommend some sort of meter. This is a Fluke tester, so I can test for voltage, I can test for continuity, I can test amperage. So any multimeter tester will work. You're gonna want some electrical tape and possibly wire nuts. Now that we've gotten our tools situated, the first step in this project is going to be turning off power to the existing receptacle. So for this, I'm just going to grab my outlet circuit tester. You just simply plug it in. You can see the two lights. So this first off tells us that it is wired correctly currently. And I'm going to go upstairs into my panel and I'm going to turn off the circuit breaker. Now, it should be labeled upstairs, but it isn't always. So if you don't have this tool, which I really recommend getting one of these, you can plug in a lamp or you can plug in a radio. And we're going to go upstairs and we're going to shut off the breaker. Now, why might a radio work? Well, you can go up, you can hear the radio. It's in a different room, and you turn off the panel and the radio will turn off. Or you plug in a lamp. And once the lamp turns off, you know the power's dead, and then we're going to test it. This situation, it works just like a lamp. It tells us that there's power here, and I'm going to go upstairs. Hopefully it's labeled. We'll find out. And I'll turn it off. I'll come downstairs, and I'll see that it's shut off, and then we'll test from there. So let's go turn off the breaker. So I'm at my breaker, or my panel. Now I have to find the breaker. Hopefully it's labeled. Let's find out. Let's see. We're going to be looking for something hopefully labeled like downstairs or washer. This is going to be for our AC, master bedroom, bathroom, hallway. This one's unlabeled. Garage, bedroom, TV, bathroom, garage, living room. This is our main, dishwasher. All right, we got 3 unlabeled. Kitchen, countertop, dining room. Ooh, dryer, well, and GFCI under panel. So, as you can see in this situation, it's not labeled. So I'm going to have to go through, turn off breakers until that light downstairs turns out. So we'll cut through after I find which breaker this is. So I've gone through and identified it. What I will do is I will show you the procedure of, imagine you went through all of these, because it's not labeled. So we'll flip it off. Let's go downstairs. As you can see, the lights, they're no longer on. So that means we found the breaker, and you can always test it by it's easier if you have a partner. So you can have somebody turn it off, lights turn off, turn it back on, lights should turn back on, and then finally you turn the breaker back off. So we know we found the breaker, and now I'm just going to go upstairs and label it as washer. Here's my breaker that I have shut off. It's in the off position, and I'm just going to say washer. There we go. So now we know which breaker it is in the future. You can also see it says 20 amps. All right? That means I can put that 20 amp receptacle on there, and it's also 12 gauge wire that we saw. 12 gauge wire is good for 20 amps. So we know we can put that 20 amp GFCI receptacle. So our first order of business is going to be removing everything out of the receptacle. So I've just unplugged the washer, and now what we are going to do is we are going to unscrew this faceplate. So usually it's just a 632 screw, flat blade, and you just unscrew it just like that. Okay. Now you have to be careful, because even though we're pretty sure we shut off the power, we're going to have to double check. So that's where this non-contact voltage tester comes into play. All right. Now this uses a ground reference, meaning you can't totally rely on this. So it's picking up static right there. That's how you can test it. Rub it against your shirt. It'll beep, light up. So if we test up here, right? Dead, right? The wire's dead. You know that this is live. And then you go back to dead. All right? Should be dead. Cool. Now we're going to pull the wires out. Or we're going to actually unscrew the receptacle. So, flat blade. Let's As you can see, these screws are a little rusty, so it furthers my point of why we need to have a GFCI down here. Not only is it required, but you get why it's required. There's clearly moisture. This is a washer machine, all right? There's obviously water here. It's a good idea to have a ground fault circuit interrupter. Not just because it's a requirement. Okay, so now what I've done, you've seen what I did. I just pulled this yoke right here. That's what they call these metal tabs on the receptacle. This is grounded, the yoke is, and we're not totally sure, right? Is the power dead? Look at that. We can see there is a little bit of the conductor exposed. So whoever installed this previously did not cover this up properly. They did not strip the wires back. So what I have done is I'm just getting my tester ready. So we've tested it first with the non-contact. Now we're going to see, is there voltage present? Okay, so I'm just going between my hot, which is black, touching ground. It says 0 volts. Now I'm going hot to neutral, 0 volts. And now we're going neutral to ground, 0 volts. We're good. We know the circuit is dead. We killed it upstairs. We tested it with our non-contact voltage tester. And now we have triple confirmed that the power is off with our tester. What we can do from this point is we can pull out this receptacle. Now, there's no screws on the side of this old type. Yours probably will have. It does have a ground screw, but we're going to remove our ground last. I like to remove it in this order. I like to do hot, then neutral, then ground. So all we have to do, let me move this washer so we have a little bit more working area. All we have to do is cut these wires. So I actually have a pair of small diagonal cutters, but you can get away with usually your wire strippers. You can fit them in there. But I want to save as much of this wire as I can. So I'm just going to cut it there at the base. 1, 2, and 3. Perfect. Now we are going to be ready to put in our brand new GFCI. All we have to do for the GFCI is you look on the back. On the back, it will say, on mine it says, and it will say on yours too, it'll say line and load. Okay? So for me, I only care about line because there is no other extension of the circuit. Now for you, your situation might be different. You might have multiple receptacles in a line. That's how we wire a house typically, is you're going to have wire go to the first receptacle, and then it's going to go on to the next one in parallel with the next one with the next one. So if you want to protect more than just the receptacle here, you're going to have to care about what's on the load side. So if you had 10 receptacles that went on after this, you'd have the incoming wire that comes from your circuit breaker that goes on the line, and then you have the outgoing wire going to the rest of the circuit going on the load side. So that way when this trips, the rest of the circuit is also GFCI protected. There's no more power after it trips. So for me, I only care about line. We're going to strip back some of the wire. It's going to be a bit of a tight fit, as you can see. So this is 12 gauge, so I just go to my 12 gauge mark. Strip back some of that wire. Pull it off. There we go. We got bare copper exposed. Do the same thing with my neutral. Again, my circuit is dead. Perfect. I'm going to straighten that wire out as much as I can. Now this is what we call old work, right? So this wire is already existing. On a new build, you're going to want to have 6 inches hanging out of the box. Because see how tight this is? We're going to have very little room to work with. So, GFCIs are nice, especially the new ones. You can see there's these holes there. I can directly just plunge my wires right there in the hole. But you can also hook your wires around, and depending on the make and model of your GFCI, you might have to hook them around. So if you are going to hook, you have to do it clockwise, meaning when you tighten that screw, it's going to tighten around the screw. If I had it counterclockwise, meaning the hook was facing to the left, when I tighten the screw, it's going to open up. We have to have it on the left side of the screw curved that way. So that way when you tighten the screw down, the wire itself tightens. If you have the other way, right, and I'm going to spin it to the right because that's how you tighten the screw, it would open. In this situation, I don't care too much because I'm just going to be putting the wires in the back of these holes. So it's just going to clamp down on it. So these are going on the line side. There's my line. First, I'm going to connect my ground, which is this bare copper wire. It's going to go on my green ground screw. Let's make a little hook. See how I made it to the right? Now it's going to hook onto my green ground screw. Not much room to work with in this guy. Okay. All right. So we've hooked it to the right. Now all I'm going to do is I'm going to squeeze it around the screw so it's nice and tight. And then you simply tighten up the ground. All right, ground is tightened up. Now, I have the line right here. These are going the line side. We're not putting anything on the bottom. So since we're not putting anything on the bottom on the load, I'm going to tighten these guys up so they don't rattle. Okay. Now, I'm going to do my neutral first. Neutral goes on the, which is white, goes on the silver screw, okay? Black, which is going to be hot, is going to go on my brass color screw, right? So silver is white, black is brass. See how I just inserted that right there in the hole? There's my silver screw. We're just going to tighten this down. Make sure it's nice and tight. Don't want these coming undone. Beautiful. Now we're going to do the same thing with our black. Push it all the way in. All right, good and tight. Now, very importantly, I'm going to wrap it, especially because it's in a metal box. I'm going to wrap it with some vinyl electrical tape. And we're just going to cover those screw terminals. Why do we do this? Well, this screw is hot, right? This is energized. This is grounded. So what happens is if this screw accidentally were to touch this, especially if we're removing it and doing work in the future, well, it's going to short. And that is going to create a little arc fault, you know, that's going to be dangerous. It's going to create a spark. You don't want that. So this just makes it a lot safer. Wrap it in some electrical tape. Beautiful. That's done. Okay. Now, you simply have to push it back in. Now, there is no code stating whether you have to have ground terminal facing up or having it facing this way. So I, personal preference, I always recommend having the ground terminal facing up. Why? Well, in case you have something half plugged in, okay, half plugged in, like let's say we had it like this, half plugged in. Well, I don't know, something crazy happens, a piece of metal goes down, it's half plugged in. Well, boom, we just had a dead short across my neutral and my hot. Versus if I have it like this, I'm much less likely to have something bad happen. It's just going to hit the ground first. So let's push this guy back in the box. In a house, you're going to have more than likely solid wire. So it's actually pretty easy to work with. It's pretty flexible. It is stiffer though, right? So don't worry, push it in the box. Just tighten these guys all the way down. Try to get that as straight up and down, perpendicular with the floor as possible, because it looks nice that way. Tight. You want to make sure it's tight so that way it doesn't move anywhere. You know, I'm sure you've had that experience where you plug it in a loose receptacle and it's shaking all over the place. Make sure it's nice and tight. Now, simply put that faceplate back on. Now you notice this one doesn't fit. So, luckily, in most packages, they come with a new faceplate. Not always, but mine did. I like to have them going vertical, so at least I know I was the last person to work on it. Because if somebody else worked on it, they're not going to always do vertical. You know, they may have it cockeyed. So I know my work is good. Up and down. Perfect. Now, let's go turn the circuit breaker back on. We are back at the panel, and I'm just going turning the circuit breaker back on. It didn't instantly trip. That's always a good sign. That means we more than likely didn't do anything wrong. Now, when you first turn the circuit breaker back on, what you're going to see is it's going to light up because you have to reset it. Factory comes tripped. So, you just go over to the reset button. You reset it. You heard that little click. So we should have power. I have my two lights. Look at the code here on the back, but most often it says 2 lights equals correct. So my 2 lights are on. I did it correct. 2 lights are on the bottom. We did it correct. Now, here's the important part. Will it trip under a circumstance where there's water and there's a ground fault? Well, luckily there's a test button. Look at that. We tested it. Power's off. Reset it. Press it back in. Boom. Power's restored. So, there we go, folks. Look at the back of your box also. A lot of times it'll tell you the interval frequency of when you should test. I believe this one is once a month or once a year, but always test your GFCIs because you don't want to rely on them and then have them not work when you need them. Now, last but not least, I'm going to put on my GFCI sticker. It comes with the GFCI. Most brands out there make it a requirement. It comes with there. So just peel off the little sticker and putting the GFCI protected outlet. Boom, there we go. It's labeled. Now the last step of this project is to make sure that the voltage at the receptacle is correct. So we know that the hot is on the correct terminal, we know the neutral is on the correct terminal, and we know the ground's on the correct terminal, right? We use this device. We know that it didn't trip. We know that it actually trips and resets when we press the buttons. So let's just confirm that we have voltage right. So this is the ground, and this is the hot, and this is the neutral, right? So just stick the terminals of your tester in. So as we can see, I have 117 volts. That's good. Has to be somewhere really close to 120 volts. I should have from neutral to ground, I should have 0, right? Because they share the same spot inside my panel. Now, from ground to hot, I should have about 120. There we go, 117 volts. So we are all good. So just plug in your device, which is my washer, and there we go. We are safe. Thanks for watching today, everybody. Make sure you leave a like, follow, and subscribe. Super happy with how this project turned out. There's the old receptacle that's gone, and we've replaced it with this beautiful GFCI. So I can live knowing that I have a much safer home, and I hope this taught you something. Thanks for watching. Bye.